In this lesson, we're going to be finding exact values of trig functions. This time we're going to be using multiple angle formulas. So let's get our formula sheets handy, close by. Let's locate those multiple angle formulas. Okay, right below the unit circle, you're going to see double angle formulas. Those are the formulas we're going to be using. Multiple, double angle, synonymous. All right, let's take a look at the formulas we're going to be using. It says sine of 2 times angle U is equal to 2 times sine of angle U times the cosine of angle U. Cosine of 2 times angle U is equal to cosine squared of angle U minus sine squared of angle U. Or also it's equal to 2 cosine squared of angle U minus 1. Or it's even equal to 1 minus 2 sine squared of angle U. So you've got 3 formulas here that all are equivalent to cosine of 2u. For our purposes, I think we're just going to use this first double angle formula for cosine of 2u. We could use any of them. It doesn't matter. We're going to get the same answer. But I think just to kind of all stay on track, we're going to use this formula right here. I do want to point out that why are these formulas right here equivalent? Okay, look at and see why this formula equals this formula. In this version of the double angle formula for cosine of 2u, notice that there's no sine squared u. So coming back to this previous formula, how would I get rid of sine squared u? Well, if you were to insert a Pythagorean identity, if you were to replace sine squared u with 1 minus cosine squared and distribute the negative and clean up, you would get this version of that cosine 2u formula. Likewise, where did this version come from? Well, look at this version of the double angle formula for cosine 2u. Notice that we're missing a cosine squared u, as in this first version. So how would we get rid of cosine squared u? Well, we could insert 1 minus sine squared u, and then clean it up, and we would get this version. So these two versions right here are just simply using Pythagorean substitutions from one of these two terms right here. So for our purposes, we're just going to all consistently use this version of the cosine 2u formula. Tangent of 2 times u is equal to a fraction again. We saw that in a sum and difference formula for tangent. The numerator is now 2 times tangent of u divided by 1 minus tangent squared of u. So these are the formulas, kind of keep them handy, that we're going to be using. All right. Coming back to our problem here, this is on page 530. This is problem number 10. There's a given figure. It says use the given figure to find A through H. Well, I didn't label this triangle, so let's go ahead and do so right now. It is a right triangle, so let's go ahead and put that right angle in there. It's always good to show that. Okay, up here, this angle is the angle we're going to be working off of, not this acute angle, but this angle. And we'll call this angle theta, because in A through H, notice that we're all dealing with the angle called theta. This leg length is 5, and this leg length is 12. So applying Pythagorean theorem, okay, this will be 13. So in the textbook, you were given this figure. Everything was labeled except for 13, but we had to find 13 by using Pythagorean, the Pythagorean theorem. All right, so for problem 10, let's look at A. A says find the sine of theta. Well, that's not a double angle because that coefficient in front there is just 1. It's as we know it. In a right triangle, it's opposite over hypotenuse. So remember, theta's up here, opposite is 12, hypotenuse is 13. Likewise, cosine of theta adjacent over hypotenuse. And tangent is opposite over adjacent. Oops, 12/5. Okay, so nothing new there, all just very familiar. Okay, in part D, it says find the cosine of 2 times theta. I certainly wish that it was as easy as taking 5/13 and multiplying it by 2, but I'm just going to lightly write this. Don't you write that, please. But cosine of 2u is not equal to 2 times cosine of theta. Oh, I don't know why I said u. Sorry. Cosine of 2 theta does not equal pull the 2 out front and double it. Okay, nope, it's not. It's where we have to use the double angle formula, also known as multiple angle. Okay, well, how do we find cosine of 2 theta? Well, we go to our formula sheet, and we write down cosine squared theta minus sine squared theta. And we'll come over here. Let's first of all make sure that we understand that this term and this term, they're squares, but I can take the square off of the cosine function and wrap it around the parentheses here. So we're going to find cosine of the angle first, theta, and then after we get that value, we'll square it. So in print, I'm going to take that square off and put it on the outside like this. Okay, now that we have a single theta, a coefficient of 1, then we can go to the formula or to the right triangle and find the values. We already know the cosine of theta, and we know the sine of theta. So cosine was 5/13, and sine of theta was 12/13. Now we just do the math and clean it up. Squaring this fraction means square the top, square the bottom, so that's 25 over 169 minus, likewise here, square the fraction, that becomes 144 over 169. Noticing we have a common denominator, let's rewrite this as a single fraction. So 25 minus 144 is negative 119. So that's our answer for cosine 2 theta. All right, let's find the tangent of 2 theta. Well, I wish we could just double that number right there and be done with it, but it's not that easy. So we go to our formula sheet, and let's go ahead and write that formula down. The numerator would be 2 tangent theta, and the denominator is 1 minus tangent squared theta. I'm going to go ahead and get it ready by putting the square on the outside and put tangent of theta right here. Okay, tangent of theta was 12/5. Denominator 1 minus, and we're going to square the 12/5. All right, the tangent one always seems to give us a lot more algebra to deal with, computation. So let's take care of the numerator. Let's clean that up. Okay, remember this is 2 over 1 times 12/5. So this is 24 over 5, not 24 over 10. We don't multiply the 2 into top and bottom because 2 is simply 2 over 1. Denominator, 1 minus, let's square the fraction. That's 144 over 25. Okay, a little more cleanup. The numerator's good. Let's work on the denominator. So this is 1 whole. I'm going to change this 1 whole to a fraction that's 25 over 25 to get a common denominator. So in the denominator here, I'm going to have 25 in this denominator, and 25 minus 144, I believe that was negative 119. I think I'll just come down here. So let me take 24/5. And instead of dividing, let's multiply by the reciprocal of the denominator, 25 over negative 119. At this point, before I multiply the two numbers on top together and the two numbers on bottom, I'm going to make the numbers smaller. I see 5 divides into 5 once, and 5 divides into 25 5 times. So now completing the multiplication on top, that would give 120, and in the bottom it's 119, and it is a negative answer. And again, the negative it doesn't matter where you put that, top, bottom, out in front. Let's look at these next 3 then. We're asked to find the cotangent of 2 theta. Well, if you go to your formula sheet, you don't have a cotangent of 2 theta, okay, formula, but you do have a tangent of 2 theta. So how we're going to handle this is I'm going to say, you know what, cotangent of 2 theta is actually the reciprocal 1 over tangent of 2 theta. Well, I already found the tangent of 2 theta. So cotangent of 2 theta is actually the reciprocal of, wait, where was tangent of 2 theta? Tangent of 2 theta is right here, this last problem. So this is just the reciprocal of this. In other words, it's 1 over, and then we insert tangent of 2 theta, which is negative 120 over 119. But we just know that this all means multiply by the reciprocal. You just reciprocate this fraction, and you're finished. Notice I put the negative on top because it doesn't matter where you put it. So if you don't have the formulas, think about reciprocal identities to help you. Okay, secant of 2 theta. Nope, that's not part of my formula, but I do know that secant's reciprocal is cosine, so let's make this correct statement here. So it's 1 over, let's find cosine of 2 theta. We found that in part D. And then when you multiply by the reciprocal, you get negative 169 over 119. You might be thinking, well, do I really have to show this step if I know it's the reciprocal of what I already found up here? No, you don't have to. You can go straight from here to here by observing that you would find the reciprocal of cosine of 2 theta. Same thing with cosecant 2 theta. However, we never did find sine of 2 theta. So this is equal to 1 over sine of 2 theta. That wasn't part of our previous work here, so we're actually going to have to define this. So coming down here, I've got 1 over. Now, sine of 2 theta, go to your formula sheet. We do have that formula, and that's equal to 2 times sine of 1 theta times cosine of 1 theta. I'm going to work across here. So sine of theta times cosine of theta, we found that way back up there. That's 12/13, and cosine of theta was 5/13. Okay, we just have some more work to do here. Okay, remember this is 2 over 1. I don't see anything across that divides out to make our number smaller, so I'm just going to have to multiply 2 times 5, getting 10. 10 times 12 is 120, and then the denominators multiplied gives us 169. So keep, change, flip, we're going to get an answer of 169 over 120. Okay, so that's using the multiple angle, or specifically in this case, we're using double angles. We don't have a triple angle formula, but we do have the double angle formulas. All right, continuing in this section using multiple or double angle formulas, let's look at 21. So we're finding the exact values of cosine or sine 2u, cosine 2u, and tangent 2u. So we're going to have to use all three of the formulas. All right, we don't have a picture to work off of, but we're going to draw a picture. It says, given that sine of angle u is equal to -3/5, where u is in between 3 pi over 2 and 2 pi, what we're going to do is we're going to draw the right triangle. Okay, but this is giving us specific information about a quadrant that this angle or this triangle belongs in. Well, remember 3 pi over 2 is down here and 2 pi is right here. So it looks like they want me to put my right triangle in quadrant 4. In the previous problem, you were presented, the presentation of the problem was not within a quadrant, so we just allowed everything to be positive. Okay, there was no given information that told us about a specific quadrant. This does. So we have to be mindful of that quadrant. Okay, so this is angle U's triangle. So this is angle U. So let's come back to the given here and label this right triangle. So opposite over hypotenuse. So from here, the opposite is 3, but it needs to be negative. Hypotenuse is always positive. Applying the Pythagorean theorem, this leg length would be 4, and it is positive since we're going in the positive x direction. Okay, let's come over here and find sine of 2u. So accessing the appropriate formula, I'm going to come down here. Sine of u, well, that was given, that's -3/5. Now we have to extract the cosine of u. U is here, adjacent, hypotenuse, 4/5. Okay, think of 2 as 2 over 1. And so I don't think anything will divide out. So multiplying all the numerators together gives me -24, and the denominators are 25. Okay, I'm going to put cosine 2u here. Remember, cosine 2u is cosine squared u minus sine squared u. So, but let's go ahead and get it ready by putting cosine u squared with parentheses here, square on the outside, and likewise with sine u, instead of putting the squares on the trig functions. It eliminates one more step of writing. All right, see, cosine of u was 4/5 and sine of u was -3/5. So our work to do here is square the fractions. So square top, square bottom, 16 over 25 minus, from this minus, squaring this fraction gives 9 on top and 25 on bottom. All right, I'll just work to the side to save myself room for tangent down here. 16 minus 9 is 7, so my final answer is 7 over 25. It always seems like there's more cleanup with tangents, so I've got all this space right here. I'm going to work from far left to far right. accessing the double angle formula. I'm going to go ahead and get this ready here by pulling the square off the tangent, and this is tangent u here. And this is equals, I'm just wrapping it down this way. Tangent, we haven't found that yet, I don't believe. So here's u. Tangent is opposite over adjacent, so that's going to be negative 3/4 on top. And then 1 minus, and then we're going to square the negative 3/4 down here. I think it's going to be too crowded there, so I'm going to work up here. All right, let's multiply the numerator together. So we're going to get 2 over 1. I could divide out the 2's, and I'm going to end up with negative 3/2. Denominator is 1 minus, let's square this fraction, that's 9/16. Let's clean up the denominator. Let's get 16 over 16 to be equivalent to 1. So 16 minus 9 is 7, and put that over 16. So we're going to have negative 3/2 times 16 over 7. And you can go ahead and multiply the tops and bottoms together, but I see that to make the number smaller, 2 divides into 2 once, and 2 goes in there 8 times. So I won't have to reduce at the end. So I end up with negative 24 over 7. Okay, as a final problem, we're actually going to be using a calculator to approximate the solutions of the equation in the interval including 0 because of the bracket, but not including 2 pi because of the parenthesis. It says use a graphing utility to approximate the solutions. Where is this expression equal to 1? Well, there's several ways that you can handle this in the graphing calculator. One way is you could set the equation equal to 0. This is one way. Pull over the 1, set the equation equal to 0. And since all my work's going to be on the calculator, I'm just going to put x equals, and I'm going to get ready for all my solutions. So let's go to the calculator. Now go to y1. Make sure and do an open parenthesis because you want to square this quantity right here. And remember, when you hit sign, it calls up a parenthesis. So put in 2x and immediately close the parenthesis around 2x. And then hit plus and do the same thing for cosine. You want to close the parenthesis, but remember you had another opening parenthesis, so you want to close the parenthesis again. You want to put square on here, so square that. And then I want to do minus 1. All right. Okay, and just for the sake of making it easier with calculator work, I'm going to let y2 be 0. So what I'm doing is I'm letting y1 be the left side of the equation and y2 be 0, which that's just the x-axis when graphed. So I'm going to try and find an intersection with this graph that's going to appear in the x-axis. I'm going to try and find the intersection. That's one way. Okay, the other way is just to go ahead and leave the problem the way it is. Let this be y1 and let this be y2. And find the intersections of that graph with that horizontal line at y equals 1. I think most students like to set the equation equal to 0, but you don't have to. All right, next thing, very important, go to your window. You're wasting your time if you don't go to your window. Go to your window. It tells me that my solutions can only be between 0 and 2 pi. So this is your x min. My smallest answer, x min, is going to be 0. The largest answer I can have, but I can't include it because of the parenthesis, is 2 pi. So let's not waste our time. Let's let x min be 0, and let's let x max be 2 pi. When you hit the down arrow, it converts it to a decimal. The scale doesn't matter. I'm interested in where these two graphs are going to cross on the x-axis. So y min -5, y max 5 would certainly view y equals 0. So 0 is between these two numbers. So I think I'm good. Let me go ahead and hit the graph. Oh, I forgot to mention, and I know now why. I forgot to mention, I'm going to hit on and stop it. I'm going to hit clear. you need to be in Radian mode. So hit your mode key and go to Radian. For a previous problem that we checked, I was in degree mode. So hit Radian. Now hit graph. There we go. Okay, look how many times that graph is cutting through the x-axis, intersecting with y equals 0. It appears that I have a solution here at 0, one there, here, and then all these other crossings. 1, 2, 3, 4, 5, 6, 7, 8. It looks like I have 8 answers. I've got to go through and find all those 8 answers. I'm not sure if that graph starts at the origin, so what I might want to do is go back and reset my window. I want to see something that's over here to the left of the y-axis. So let's go to the window and just adjust that to maybe -1. If x min is -1, then I can really see the y-axis. There we go. Yeah, I think that's a solution at the origin. All right, so now let's go ahead and find and see if that's 0, because if it is 0, we can include it because we have a bracket right here. So I'm going to go second trace, and I'm not going to find the 0 because I'm going to find an intersection because I have 2 y's. Enter. Notice that it put me on y1. It tells me up here in the top left. Okay, I want to come over here close to 0. So you can kind of scroll to the left, or if you want to go to y2, hit the down arrow or the up arrow. The up and down arrow toggles you between all the different equations you're graphing. That way, when I hit the left arrow, it gets me there quicker. Okay, so I'm going to put myself on what I think is a solution. Okay, and at this point, it asks me for first curve. I'm going to press enter. Second curve, yes, that's the other equation. Press enter. Guess, no. So the intersection is x equals, notice that it's scientific notation. E to the -13 means take this decimal right here at 2.1, move it 13 places to the left, filling in zeros. Well, the calculator struggles to return a 0 answer, but this is 0. So I can include 0 as one of my solutions because 0 has the bracket around it. 0, comma. Let's go through and find the other solutions. So clear, second trace again, 5 for intersection, and just right arrow. Okay, if you want to stay on y1, that's fine. If you want to get there quicker, go up or down, get to y2, and hit right arrow. Okay, put yourself on what you think is the next solution. Hit enter 3 times. 1, 2, 3. Make sure that the cursor shows up at where you want that intersection. Round to 3 decimals. 0.785. Okay, and then continue. Clear it. Intersection again. That's the next one. Enter 3 times. 1.571. I'm starting to see a pattern. I know that 0.785 is actually the decimal approximation for pi over 4. I also know 1.571 is the decimal approximation for a half pi. I'm thinking that I'm counting by a quarter pies. 1 pi over 4, 2 pi over 4. My prediction is that the next solution will be 3 pi over 4. If you change that to a decimal, I think you get 2.356. So let's confirm that that's the next decimal approximation by doing our intersection again. 1, 2, 3. 2.356. Yep. You can continue just doing all the decimals, but if you observe a pattern, like right now, I feel like I'm adding a fourth of pi every time. So if I add another pi, or fourth pi, it's going to be pi. Another fourth pi would be 5 pi over 4. Another fourth pi would be 6 pi over 4, or 3 pi over 2. Okay, well, now I have to go ahead and come over here and count off again. So that's 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, or 6 pi over 4, and that's 7 pi over 4. So my last solution would be 7 pi over 4. If I went to 8 pi over 4, remember that's 2 pi, and 2 pi can't be included. So these are all of your solutions. Okay, if you want to just give decimals for the remaining answers that I got here, that's fine too. Doesn't matter. Okay, all right, that's it.